Are going to practice some questions on parts, how to use parts. Here I have multiplication inside the integral, x squared times x, the degree outside greater than the degree inside. So that means we have parts. And that parts will happen how many times? 2 times, because x raised to the power 2. So we just choose u is equal x squared dv, it will be equal cosine x dx. So implicit differentiation, derivative of u, it will be du. Differentiation of x squared, it will be 2x dx. I will integrate dv, it will be v equal integral of cosine, it will be sine x. Now follow the rule, u times v minus, don't forget that, integral of v du. So we will simplify that. As you see, the integral is equal x squared times sine x, it will be x squared sine x, that represent u times v, minus integral of v du, it will be 2x times sine x. So everyone noted that here I have multiplication of two functions again. And also we noted that that sign is minus, so it will be changed the whole sign after it. So that means we will make parts again for this integral. So u is equal to x, dv is equal sine x dx. So du, it will be 2 times dx. Integral of v, it will be negative cosine x dx. So we will back to complete from here, from that step. X squared times sine x minus, then you need to open bracket because that minus will be changed all sign after it. Now apply the rule again. 2x times negative cosine, it will be negative 2x cosine x minus integral of v du. So it will be minus times minus, it will be positive. Integral of 2 cosine x respected to dx, all of that respect to dx. Now we simplify more. X squared times sine x minus times minus, it will be positive 2x cosine x minus times positive, it will be negative. Integral of 2 cosine, it will be 2 sine x, all of that plus c, and that is the final answer. Also, you can use the table method to find the integral, because I have in parts 3 types of questions. Here, we can use the table like that. U and the dv. One row represents the question, here x squared, where it's the easiest in differentiation, and that it will be cosine x. The first type of parts, that function you need to differentiate it in the form x to the power n, so it's a derivative reached to 0. So differentiate till 0. The derivative of x squared, it will be 2x. The derivative of 2x, it will be 2. The derivative of 2, it will be 0. On the other side, I'm going to integrate. Integral of cosine, it will be sine x. Integral of sine, it will be negative cosine x. Integral of cosine, it's a sine, but I have negative. Don't forget that. What about sine? We just do that. Always positive, negative, positive, negative. So I said before, one row represents the question, so we just multiply here. That by that. That by that. So it's equal positive times positive, it will be x squared times sine x. Negative times negative, it will be positive 2x cosine x. Positive times negative, it will be negative 2 sine x, all of that plus c. So I have the same answer. You can use this method or this method as you like. But if you have x to the power n notation in the derivative, we just start to differentiate it till 0. Okay, Mister, what about that question involving ln x? Oh, in ln x, it's better to use integral method. I have a lot of type of questions for ln x. In this question, we choose u equal ln x. Why? Because I have rule 4 in differentiating ln x. And the dv, it's take dx only. So what about du? The derivative of ln x, it will be 1 over x dx. The integral of dv, it will be v times integral of dx, it will be x. Now, just apply the rule. It will be x ln x minus integral of. Here, x divided by x, it's cancelled, so it will be dx. So the final answer here, it will be x ln x minus, and as you know, integral of dx, it will be x, all of this plus c. Okay, Mister, what if I have question like this? For example, integral of 1 over x ln x. In this question, we cannot use parts. Why, Mister? Because I have product in denominator. So, we just need to attention for that. Everyone know we can write that question as integral of. If you divide through x up and down, 1 over lx, it will be 1 over x. X ln x over x, it will be ln x. All of that respected to the x. Why, Mister? Because as you know, the derivative of ln x is equal 1 over x. So in this way, you can use f prime over f. So it's equal ln of denominator. What is the denominator? It's ln x. Inside modulus value, all of that plus c. So if you got question like that, 1 over x ln x, we just divide up and down by x to write it as f prime over f. But if you have ln x like that, or integral of x ln x dx, we use the same method, where always we use u equal ln x. Now we are going to the next question. Here I have integral from 0 to 1 for 3x times e to the power 2x. We cannot use recognizing here. So also we cannot use substitution. Why? Because you cannot write f times f prime, because the here is 2x and outside I have 3x. I cannot use recognizing, so that means you will use substitution, or sorry, parts to solve that question. So which part you need to substitute here? U always equal the easiest of differentiation, which is 3x, and dv, it will be equal e to the power 2x respected to dx. So du, implicit differentiation, it will be 3 times dx. The integral of dv, it will be v, and I have here basic rule, it will be e to the power 2x and divide by coefficient of x. So the integral of from 0 to 1 for 3x times e to the power 2x respected to dx is equal u times v, which is 3 times 1 over 2, it will be 3 over 2, x times e to the power 2x, minus integral of v du, 1 over 2 times 3, it will be 3 over 2 as a constant here, e to the power 2x respected to dx. Now, it's equal 3 over 2x e to the power 2x minus integration of e to the power 2x, it will be e to the power 2x. 1 over 2 times 3 over 2, it will be 3 over 4. All of that defined from 0 to 1. Then, as you do in all definite integrals, it will be 2 brackets. Between these 2 brackets, I have minus. So in first bracket, we substitute using upper limit. That we just exchange every x by 1, every x. So it will be 3 over 2 time 1, it's 3 over 2 time e to the power 2 times 1, it will be 2 minus 3 over 4 e to the power 2 times 1, it will be 2. In the second bracket, we substitute every x by lower limit, which is 0. So we do that. 3 over 2 times 0, it will be 0. Here minus 3 over 4 times e to the power 0, which is 1. So simplify that to find the answer. Here I have like term 3 over 2 minus 3 over 4. Using a calculator, it will be 6 minus 3, it will be 3 over 4. We're just adding using a calculator. 3 over 2 minus 3 over 4 is squared. Minus time that minus, it will be plus 3 over 4 times e to the power 0. As you know, e to the power 0 equal 1. So that is the final answer. And maybe you got like that question as proof. Now we are going to another question. For example, if you have question like that, find integral of x squared ln x. X squared times ln x times ln x, and so on. It's parts. And always u is equal ln x because I have rule for to differentiate ln x. So dv, the remaining x squared respected to the x. Now, implicit differentiation du equal 1 over x dx. Integrate dv, it will be v equal x cubed 1 over 3. Now the integral of x squared times ln x respect to the x is equal. We just multiply u times v, it will be 1 over 3 times ln x side bracket times x cubed. We cannot multiply x here by the inside of ln. Minus integral, just do that in your exam. 1 over 3, it's a constant still outside. X cubed divided by x, it will be x squared respected to the x. So it's equal 1 over 3 x cubed rearrange times ln x, because some students multiply x times x cubed here. We cannot. Minus, for this one, we adding 1 to the power, it will be 3. 1 over 3 times 1 over 3, it will be 1 over 9, all of that plus c, and that is the final answer. So now we are going to integration using partial fractions. How to know I will use partial fractions? If you have in denominator more than one factor, maybe you have quadratic equation can be factorized or cannot be factorized. But first of all, I need to remind everyone here by that, you know, the integral of 1 over x to the power 1 respect to the x is equal ln for modulus value of lx, all of that plus c. And also if you have integral of any constant k divided by ax plus lb, where that is linear expression not raised to the power inside bracket respect to the x, it's always equal the constant up k still and the coefficient of x down here still times ln for the denominator ax plus lp, all of that plus c. So if you have fraction involving in denominator more than one factor and that fraction is proper, and you know that proper means the degree of numerator less than the degree of numerator, so direct we can use partial fractions, or we can express that fraction into partial fraction, then integrate it using the previous rules. For example here, in this integration I have integral of fraction, the degree of denominator 2, the degree of numerator 0, because it's constant value, so we cannot use f prime over f. But here I have quadratic expression. So let's check if we can factorize that or not. X squared plus 5x plus 4. So we just factorize that as a factors. As you know, x squared, it will be x times x. Two numbers have product 4 and sum equal 5. So I have 1 and 4. Last sign positive. So the middle sign are similar, like the middle. positive and positive. Or you can use mode 33 to find the solution. You will get x equal -1 and the x is equal -4. Then switch that to other side and that to other side to get the factors. So here we rewrite the question as integral of 3 over x plus 1 times x plus 4. All of that respected to the x. Now I have fraction included 2 factor in denominator, and that fraction is proper, degree of numerator less than degree of denominator. So first of all, I will take that fraction to express it into partial fractions, as you know from grade 11, 3 over x plus 1 divided by x plus 4, all of that respect to the x. To express this into fractions, into partial fractions, we look how many factor in denominator. I have 2 factors. So the first factor with the first fraction, the second factor with the second fraction, where a and b 2 constants to be found. Now to remove this denominator, we just multiply all by the original denominator, x plus 1 times x plus 4. So we will get that 3 is equal. We just multiply here 3 times x plus 4 plus b times x plus 1. All of that. That is the most important identity. Now to find the values of a and b, we use the zeros to eliminate variable and find the other. So the first one here, a times x plus 4, that is a. Then b plus x plus 1. What is the value of x which make that 0? It's -4. What is the 0 of that factor? It's at x equal -1. So we just substitute here at x equal -4. So when x equal -4, that it will be 0 of this factor. So a is eliminated. So I got 3 equal -4 plus 1, it's -3b. So the value of b is equal -1. By the same way, we use the other 0, x equal -1, to eliminate p. So we have that 3 is equal -1 plus 4, it will be 3a. So we state the value of a is equal 1. Now we will back to our integral. It's the integral of, we substitute that fraction by its partial fractions. What is the value of a? It's 1 over x plus 1. What is the value of b? It will be -1 over x plus 4. All of that respected to the x. So using the rules, it will be ln x plus 1 minus ln x plus 4, all of that plus c. And also you can simplify more. Why? Because I know negative between 2 ln means we change that to be division. You can write it as x plus 1 over x plus 4, all of that plus c.